Throughout chapter 2, we've talked about functions and different kinds of functions and doing different things with each of those functions. Today kind of ties into that, but it's going to be more kind of like story problems or scenarios where we can use different kinds of functions to represent like a situation that we have. And there's 3 different kinds of variation that we're going to look at. You've seen probably at least 2 of these before. And then the third one is going to be kind of a combo of those 2. So the first kind of variation is what we call direct variation. Direct variation uses the formula y equals k times x. And it's just kind of a generic formula. What we basically mean by this is the 2 variables are directly related. As x goes up, then my y value goes up. The k value is what we call a constant. So a real basic example of direct variation, because you're going to see some story problems today, and it'll usually tell you in the story problem that these 2 variables are directly related or whatever type of variation is being used. So it's pretty easy to determine what type of variation we have. But just so you kind of know, like an example. So a situation where you might see direct variation, and it's in a place that we use it all the time, would be like somebody that makes $12 an hour at a job. That would be my constant, okay? If I work 1 hour, or I work 20 hours, or 40 hours, or whatever I work, I'm still making $12 an hour. The $12 doesn't change. Okay, so it remains constant for any number of hours that I work. In that situation, X would be the number of hours that I work. So if I worked 20 hours, I would take 12 times 20, and that would tell me what my paycheck would be before taxes. So as my hours go up, my pay goes up, right? More hours I work, more pay I get. So those 2 are directly related to one another, and that's where the direct variation comes in, okay? I will put this up here, and I'll show you where this comes from. A lot of the times today, we're going to have to find out what k is. And to find out what that k is, because they won't necessarily always tell me what the constant of variation is, then I'm going to divide by x to get k by itself. And so this would be kind of like the formula that we would use to find out what k is. Take the y value divided by the x value, and that gives me my constant. You don't necessarily have to memorize this part right here, because it's just using the original equation and solving it for k. Okay, second one is what we call inverse variation. Inverse variation very similar, except we do division instead of multiplication. And this could be vice versa, but as one variable is going up, the other one's going down. So they have like an inverse relationship to one another. They're going opposite directions. This one, I always kind of, just kind of think about an easy example that you can use to explain. I think about like the winter time, right? If we get a really big snow, the ground is covered with snow for quite a while, right? And then eventually what makes the snow go away is when the temperature rises, right? So as the temperature rises, the amount of snow that's left on the ground is going to go down. Okay, they're going to have an inverse relationship. If we said how much snow is on the ground, if we have a foot of snow and the temperature gets up above, freezing, then eventually it's going to go the opposite direction. Okay, so those two have an inverse relationship. The temperature goes up, the amount of snow goes down. Same thing here. If I wanted to find k in this case, I would multiply by x on both sides. So in order to find k here, we would do x times y. And all that is just a little formula to help you remember how to find k. But you can always go back to the original equation. These are going to be the equations that I give you. I'm probably not going to give you these here, but it's just a way to find k and using the original equation. Okay, the last one is what we call joint variation. It's kind of like direct variation, except we add another variable onto the mix. So we're still just multiplying things together, but we multiply by another variable. And once again, we see the k in there. K remains a constant every single time here. Doesn't matter what type of variation we have, k is always a constant, so it's always going to be a number that doesn't change throughout that problem. An example of where we've seen this before, area of a triangle formula, 1/2 base times height. Okay? We don't necessarily say that they are jointly related when we talk about it, but the area of the triangle is jointly related to the base and height of the triangle, is how we could say that. So there's two variables coming in the mix here. The 1/2 always remains constant. The 1/2 is always part of the formula no matter what. The base is going to change, the height's going to change, which changes the area. If I wanted to find k here, I would take y divided by xz, and I would keep xz together. You could divide by them separately, but either way you do it, you have to take y divided by x and z. So either multiply x and z together and then take y divided by that, or divide by x and then divide by z, but you got to do it a couple of times. Okay, so those are the three that we're going to keep coming back to today. And I'm going to show you 3 examples of each one of these, and then we're going to do some story problems. And I'll probably go and pick a few out of the textbook to do a couple of examples with you out of the textbook. And then we'll start working on homework. So here's what the problems are going to look like today. Y varies directly as x. And as I told you, I mean, it's going to be pretty obvious what type of variation we have, because right there in the problem it tells us directly, which means we have direct variation. So immediately, when I see that, I know this is the equation that I'm using. And then they're going to give us some information. They're going to say if y equals 3, when x equals 12, then we want to write an equation for this variation. So what we're missing is we're missing k. We have no idea what k is, so we got to find out what k is. And this is where you can do what we did before. You can go 3 equals k times 12. And then to get k by itself, we're simply just going to divide by 12. And that's our equation. We just take k, we plug it back in for k, because that k value will stay the same then for that particular problem, and that would be our constant. So they don't just come right out and tell you what the constant is. You just have to find out what that is. There will be a few problems today that are going to take it one step further. And it'll say something like, if y equals 3 when x equals 12, then what is y when x equals 10? And so then I would have to take 10, plug it in for x, and find y. So in some cases, you might take it one step further, but for this one here, I'm just going to stop, show you how to write the equation. And then I think mostly the story problems are going to ask you to take it just a little bit further. Okay, the second one that we did, y varies inversely as x. Once again, I see that key word, inversely. And so that tells me immediately that I'm going to use this equation. Every time it says inverse, it's y equals k over x. Those three that I gave you on that very first page of the notes, those are the three that I'm going to give you. Okay, so those are just generic. When we get to story problems here in just a little bit, the variables are going to change. It's not always going to be y and x. You might use, like we showed you, like area base times height, right? So it's still the same formula, but your variables might change. Y and x are just the generic variables that we use here. So on this one, if I said, if y equals 3 when x equals 99, then once again, write an equation. We're going to take that information we're going to plug it in. And then we're going to solve for k. Well, what would we have to do here to get k by itself? Yeah, multiply by 99. So 99 times 3? 297. That's my k value. So then when I finish this out, I'm going to plug that back in for k. I just go back to the original equation. I input the k value that we now have, and that's my equation. So the math here today is not extremely difficult, right? It's just multiplication, division kind of things, but we just got to make sure we're applying it the right way and that kind of thing. So the hardest of the three is inverse, or jointly, sorry. And I'm actually going to give you one here that is jointly, but it's also going to be a combined variation, because we're going to see that as well, where we have a joint and an inverse in the same problem. Okay? So the one that I'm going to give you here is both a joint and an inverse all at the same time. So you could have one that's direct and inverse at the same time as well. So some of these will be combined together where you have more than one type of variation that's taken place. So for this one, I'm going to write it out here first. Y varies jointly as x and z, and inversely as w. So we got all kinds of variables going on here. Okay, joint, we said we're multiplying by more than one variable. And then inverse means we're going to divide. So we're going to take this and divide by W. W goes on bottom. Okay, so jointly means we're multiplying more than one variable together. Inversely is just another way of saying we're going to divide by whatever the variable we have. So that's my original equation. So it's a joint and inverse at the same time. Okay, and then we're going to be given a statement telling us if y equals 3/2 when x equals 2, z equals 3, and w equals 4, then we're going to write an equation. Now, I'm not going to write that part out, but same directions as what we did on the last couple. Okay, they're telling me everything except for k. K is the only thing we don't know. We're trying to figure out what that constant is. So every time we get a problem like this, we're going to input all of that information into the equation that we just wrote out, and then we're going to work backwards to find k. So we're going to go 3/2, still don't know k, times 2, times 3, divided by 4. Okay, and you can do this a couple of different ways, but probably the best way is to get rid of that fraction first. So we'll multiply both sides by 4. Yeah, we have a fraction, but it's not that bad. 4 times 3 divided by 2. 4 times 3 is 12. 12 divided by 2 is 6. Okay, we shouldn't even need a calculator to do something like that. Over here, I still have 2 times 3 and k, so 2 times 3 is 6, so that would become 6k, and then we get a k value of 1. Bless you. And it's okay to get a k value of decimals or fractions or all kinds of different things, but we can also get a k value of 1 like we have here. And then to finish this one out, I don't necessarily need to put a 1 in for k, so I'm just going to go y equals xz over w. Okay, and if you wanted to put a 1 in there, you can, but you wouldn't need it, right? Because we know that there's an assumed 1 there if there's nothing there. And that would be our equation. The one thing I will tell you too, and we're going to see this from time to time, the only difference is sometimes it may say inversely as the square of w. So then sometimes they throw exponents into the mix. So then I would have to make this w squared instead of just w. So if you ever see the word square put in there, then you're just using exponents along with that variable. So just one additional thing that you could throw in there as well. Okay, I'm going to do a couple of examples of story problems with you. These are a little bit trickier because, they'll tell you what type of variation you have. These are on page... the first one's on page 169. And we're going to do number 14 together. Sometimes they tell you what variable to use, sometimes they don't. Okay, and so if you read through some of these problems, it'll say use, t for time or something like that. But then other times they just give you a story problem and they don't tell you what to use for variables, which makes it a little bit more difficult. And if you wanted to use x and y every single time, you can, but I would encourage you, like on a story problem, to use a letter that represents what you're talking about. It makes things a whole lot easier. So if I have like a triangle problem once again, and I would use base and height. So then when they give me the base, then I know where that number is going to go. It's going to go in for base, rather than trying to decide, well, x represents base, and then it becomes a little bit more confusing. So try to use letters that represent exactly what it is that we're talking about in the problem. So on this one here, it says the amount of sales tax paid on a product I'm just going to write this out. Tax is equal to, and then it's directly proportional to the purchase price. So here's what I'm going to do. I'm going to say T is tax, or you could do S for sales tax if you want to, but it makes sense to what we're using, and then I'm going to use P for the purchase price. And identifying what those two are, I think is pretty helpful, right? Because then when I start plugging in numbers and when I write my equation out, we know exactly what it is that we're talking about. The other thing we've talked about is that this one says right there in that very first sentence that it is directly proportional, so we know that we're multiplying those two together. Okay? And that would be the case. If you go to the store, right? If I go to Dillon's and buy a loaf of bread, I got to pay tax on it, right? And tax is 8%. And Hutch, I think, or around 8%, give or take a little bit. But if I go buy a car, a $20,000 car, off the car lot, guess what? You still have to pay sales tax. So I pay 8% based on my purchase price. So the sales tax on that car is going to be a heck of a lot more than a loaf of bread, right? So it's a percentage of the price, so it's directly proportional to how much you spend. So that would make sense. So to make this equation a little bit easier, we're going to use it with variables. T equals K times P. Okay, now, in Iowa, we purchased a glow light that sells for $119, and the sales tax is $7.14. So make sure that you insert, bless you, those in the right spot. Sales tax is going to be a lot cheaper than the actual purchase price, so that should be easy to determine which one goes where. Then we got to find out what K is. So to get K by itself, we're going to divide by 119. So $7.14 divided by 119. What's that give us? We got the calculator out. Unless anybody wants to do that in their head this Monday morning. What'd you get? 0.06? Okay, and what that means is in this state or in this place we have 6% sales tax, but we always write it as a decimal instead of a percentage. Okay, now here's where we're going to take it one step further. This is what I was talking about before. This is where we stopped on all those problems previously because we just said write out the equation and this is the equation, but now we're going to take it one step further and said, how much sales tax will I pay if I buy an ebook for $21? Okay, so in this case, we don't know the tax, but now we know K, and we know the price of the book is $21. So then all we got to do is take 0.06 times 21. And our tax is $1.26. So the tax was considerably less on the book because the book was only $21 than the glow light that we purchased, which was $7 tax. Okay, so once again, the math here is not hard, right? Everybody agree that, I mean, it's multiplication division. The math is not the hard part. It's just getting the equation set up right and putting everything in the right spot to help you kind of do the math that you need to do. All right, let's do one more story problem. Let's do the next page, page 170. This is number 16. Okay, just a little bit different story, a little bit different type of variation that's going on here. This time it actually tells me what variables to use. So that makes it a little bit easier. I don't have to decide what letters to use. It says the weight W varies inversely as the length L. Inversely just simply means divide. So when I write it out, W varies inversely as the length of the board or the beam. If we have an 8-meter beam, it can support 1,200 kilograms. So the 1,200 is the weight. The length is 8. And then to find out what K is, we're going to multiply it by 8 on both sides. And that would be our equation. So based on this example, based on this story, that K value will stay the same all throughout, okay? Each problem, that K value is going to change, obviously, but for this problem, the constant will remain 9,600. And we're going to take it one step further, and it says, how many kilograms can a 14-meter beam support? So now we just plug 14 in for my length and find the weight. And we get about 686 kilograms. Okay, that's all we got for today. I could give you another story problem with a joint in it, but I mean, you're kind of starting to get the idea that you just have to write the equation out, fill in the information, and use it to solve what it is I'm looking for. All right, assignment for today. Those same 2 pages, 169 and 170. If we do every fourth one, a lot of them will end up being the same thing. So when I say number 7 instead of number 9, here's what it's going to look like. 1, 5. We normally would do 9 and then we would do 13, but instead of doing number 9, we're going to insert 7 right there. So we'll keep counting by 4s, but instead of doing 9, we'll put 7 in there. And then keep counting by 4s after that. Okay, the first couple problems are just going to be like what we did at the beginning, and then you get into some story example problems.